Hi everyone, welcome to Mojo. Today, we're going to be diving into the world of traits in Mojo, a powerful concept that helps you define and enforce behaviors for different types. In this video, I've also created coding example to help you illustrate the concept of traits easily. First, what are traits? A trait defines a set of methods that a type must implement to be considered compatible. Imagine traits as contracts between different parts of your code. This is similar to interfaces in Java or protocols in Swift. Next thing is why we use traits. Let's look at an example. Now we open VS Code. Create a file ytraits.py. In this example, we have a duck and a cow. A duck can quack and a cow can moo. First, we define function makeItQuack. We pass object as obj. We use try catch block as obj.quack can throw attribute error. In the except block, we write a print function saying that this is not quack. This is the exception at runtime, as quack function is not implemented. Now we make a class duck to implement quack function. A duck can quack. This is the cow class, as cow can moo. Now we call makeItQuack function and pass duck object. Now we run file. Hence, a duck can quack. Now we pass cow object in this function. Hence, quack is not implemented, exception is raised. But the program did not show this before running the program. In dynamically typed languages like Python, you can have functions that work with different types of objects as long as they have the same method names. But this can lead to errors at runtime if an object doesn't actually have the expected method. But this is on runtime. Compiler did not show any warning when we were making cow class. How traits solve this problem? Traits solve this problem by ensuring static type checking. In statically typed languages like Mojo, the compiler verifies that types conform to the required traits before you even run your program. This helps catch errors early on and makes your code more robust. Let's see how traits work with a fun example. Open Ubuntu Terminal. This is the folder I had made. Now we open this folder in VS Code in Windows Linux subsystem. Now we create a file named traits.mojo. This is how we can declare trait named quackable. This trait has one signature of function, but not its implementation. Each method signature must be followed by 3 dots to indicate that the method is unimplemented. Next, we create some structs that conform to the quackable trait. To indicate that a struct conforms to a trait, include the trait name in parentheses after the struct name. You can also include multiple traits separated by commas. If you're familiar with Python, this looks just like Python's inheritance syntax. Implement the quack method for duck, printing quack. Implement the quack method for duck, printing moo. Define a generic function named makeItQuack. T:"quackable" specifies that the generic type T must conform to the quackable trait. Maybe a duck :T is the function argument named maybe a duck of type T. Maybe a duck.quack calls the quack method on the argument, leveraging the trait implementation. Now we define main function for calling makeItQuack function for both duck and cow. Run Mojo file. Now you can see that everything is good as quack function is implemented in both structs. If we change quack and cow, you can see that there is error. You can see the error that struct cow does not implement all requirements. If we undo this, the error has gone. Traits enforce static type checking, reducing runtime errors, and making your code more reliable. This helps catch errors early on and makes your code more robust. Thank you so much for watching. Please like, share, and subscribe.